I'm putting this game on Steam. $2.99. You can buy this and play it. Each 33,000 lines of code. I mean, this is the best one. Today we're going to be testing the newly introduced GPT-5.4 Pro model. Now, this was released alongside the 5.4 thinking models, which we have previously taken a look at. However, this model is deserving of its own video for a couple of reasons. One, it's really just extremely slow. I mean, it is quite common for results produced with this model to take north of an hour, which when you're going to make a video kind of becomes a bit of a roadblock to actually getting the video out in any timely manner. And two, it is extremely expensive. As we can see right here, the input and output price for this model are significantly higher than what one would normally expect from a model, to the point where they do actually have a comparison here of the price for input and output versus the newly updated GPT 5.4 model, and this for 1 million tokens input is $30 versus $2.50 for the GPT 5.4 thinking model. Following that, the output is also significantly increased from, it's basically 12 times as expensive to use here for 1 million output tokens. So that is kind of pretty expensive, but hypothetically, the performance is supposed to justify the price, and the Pro models have always performed very impressively, at least for my own use cases. So today's video is going to be a dedicated test of the GPT 5.4 Pro model. We'll begin with a bit of pertinent information about it. However, truthfully, even in the announcement blog post for GPT 5.4, it was only specifically mentioned around 6 times in here, and truthfully, I think a lot of interest will just be seeing some of the actual results the model gives us, so we'll heavily emphasize that as opposed to looking at any blog information and things of the sort. In terms of model specifics here, we can see the context window is the same as the regular GPT-5.4 thinking family at a little over 1 million tokens. Following that, the output tokens are 128,000 with an August 31st, 2025 knowledge cutoff. And they also do mention here that the model is supposed to be better at some web search. Now, I'm going back and forth in whether or not I want to actually enable that, and I think I will for some of the prompts that we do test this model with, and then perhaps for some we'll run it without that. Now, fortunately, although this is rather expensive to use, if you do have a Pro subscription, you can actually use this model. I've also heard folks mention that there are other subscriptions that allow access to the Pro model. I can't personally speak to that, being that I've only historically used it through the ChatGPT Pro subscription, which is $200 a month. So let's hop into that right now, and we'll begin our first test with this model, which is going to be perhaps a bit different than some of our normal style of testing, in that I want to test it on more intricate and capability testing prompts versus things that are cool but not necessarily worthy of such a slow and intensive model. So from the drop down here, we will just select Pro, and this also does have selectable thinking effort. However, it is different than what we would see with just the regular 5.4, where we have 4 potential options for thinking effort. With Pro, we only have 2 of those. We have standard or extended, and I do believe, because this is a sole dedicated video for this model, I will test it on all tests with extended thinking enabled, being that I'm not so worried about how long this takes to actually film and test. Now, I am going to also enable web search capability here as well while this is going to be performing its task, and I'm going to, well, so I pasted in, I thought I was going to paste in my prompt, I just pasted in GPT 5.4. Let me get the prompt and paste it. Now, in the interest of time, I'm going to begin this task, and then we'll take a brief overview of our prompt here. Now, this is something that I specifically tested with the newly updated Gemini DeepThink model a few weeks ago, and this was a really interesting visual result where essentially the culmination of what is going to be going on right here is that it is going to utilize something that it decides on to scan for wireless access points near me, and then try to think of an intellectual or intelligent way to figure out which ones are close together from a space perspective. So basically, a Wi-Fi signal strength could be the same 100 feet from me forward versus 100 feet from me back. And if it was just relying on the strength to identify access points that were physically close to one another, it would not necessarily work for that reason. So we're going to also be looking at how it tries to implement some form of logic to identify access points that are physically close to one another. Aside from that, we just want to see how well it actually gives us a visual display of what it finds. The Gemini DeepThink result was very, very impressive in terms of the actual way it was presented to us visually, and I would anticipate this will be as well. Essentially, it's just telling it the 3D aesthetics could be ASCII or matrix inspired, dark background, glowing nodes, the aesthetic of peering into invisible radio frequency space, and I have given it technical notes as well, because in the way it will actually go about trying to ensure that the computer can scan for the networks and things like that, it is helpful to know the specific operating system and things of that sort. So after 91 minutes and 1 second, or an hour and 31 minutes and 1 second, we did receive a result here. And something I'm going to notice initially off the bat is if we scroll through here, where we can essentially see a lot of the activity the model was performing while it was actually in the process of generating a response here. This is one of the longest kind of activity panes or thinking chains that I have seen when testing a Pro model. I mean, I'm scrolling down in this right now, and partially what we see right here is it just testing the script in almost more of an agentic manner to make sure that things are working, but this is really a very, very large amount of thought that went into this. Now, I have not yet actually looked at this at all, and I want to just talk quickly about some of the things we actually see here that were provided alongside the actual script and the result and its answer and everything like that. Something I notice first and foremost here is it seems to try to keep itself very grounded in reality in terms of what is possible with this result versus what is not possible. It even does mention something like here, because of that, the program does the best honest thing. It keeps NMCLI as the scanner and tries to augment each scan with cached IWDBM values when available, and otherwise falls back to an approximate quality to decibel milliwatt curve. The fallback is inherently approximate because percentage displays are tool specific and nonlinear rather than a universal RF unit. Essentially what I view this as saying here, and keep in mind I'm not an expert in whatever education would lead one to fully understand all of this logic, but it's saying that like some of these tools will just tell you your signal strength is like 80%, when in reality it would not understand that as much in terms of this specific task. So, and it's saying it's nonlinear rather than a universal RF unit, which we would see right here as the cached decibel milliwatt value or whatever that specific little symbol right there refers to. It also mentions here that in terms of ranging, which would of course be trying to map the access points that are actually close together from like a spatial metric. So the signal alone, as I may have mentioned prior to this, would not actually tell us in what direction or how close together two of these access points would be that it finds. So it's essentially saying here that the 3D placement is deliberately a latent Wi-Fi space embedding rather than a literal floor pan solve. With one stationary receiver, you get radial constraints but not true angles. So the code infers access point to access point neighborhood structure, meaning which access points are actually closer together from repeated signal traces, and lets the layout converge over time. So the signals that kind of fall together and then rise back up together that are at the same general strength level could be inferred to be close together from a whatever standpoint that we see here. And keep in mind, again, this is just me trying to explain this to the best of my ability. And one thing I see right here is I do actually, first and foremost, I suppose I should download this file. Very good. And then also in running this command, I cannot use this specific IF name flag with this interface name because that is not the one for my computer. But it does even mention here that you can just omit that and it will use the first Wi-Fi adapter that it finds, which on this system, because it only has one, should work fine. And this is not like a traditional test where if it doesn't load, like say we're doing the 3D printer test and we get something like this, it's like, oh, okay, check the dev tools. There's probably an error. It's not loading something in. It still just says booting scanner. So we're going to see, and this is the same exact error that I was receiving when testing for thinking earlier. Now, I will manually fix that because it's not an error that really reflects too much on the actual generated quality of this result. It's just like a stupid import error for basically the visual elements of this. It needed an import map to understand like basically how to pull what would render this. It's not really, we can ignore that basically. Frustrating, but not something that's worthy of running this entirely again just to try to get it to fix that, because it would take so long, and it's something that is kind of agnostic to the actual quality of the result we see here, perhaps from like a mathematical standpoint. Now, over time, this should change, and as we can see right here, it is going and iterating up in terms of the amount of scans it's done. It is showing us the visible access points as well, and these are set to be not actually showing the real name of the access points. It is kind of like a security conscientious thing to not show those, but I did show them in my deep think video because, to be honest with you, I'm the only Bijan in existence, so like it's not like I'm trying to mask myself, I guess could be said. I also think it's pretty cool. It's actually showing us a measurement here. When we hover over any one specific ones of these, we can also see the specific frequency, so the 5 gigahertz band versus the 2.4 gigahertz. We're also seeing the uncertainty in terms of a distance plus or minus value. It also is giving us the approximate distance of this access point from our specific computer. So in reality, this SSD1 and SSD2 are very likely the router that sits right behind me right now. And this is saying 0.8 meters, so a little under 3 feet away. And that is very, very close to reality. I don't know where the specific adapter in this computer sits. Maybe the antennas probably run up through the screen, as a lot of laptops seem to, but we also see the signal in decibel milliwatts that's being measured. Now, as I zoom out right here, I still have to say though, and this is something where my understanding of this will become a limitation, because I don't know if it's actually possible to have these move around in different like arrangements here like we saw in the Gemini Deep Think video. Now I'm actually just going to have this continue scanning for a while, and then we'll time lapse it and take a look at just how some of these things evolve, I suppose, over time. So this has now performed 41 or 42 scans, and we can see the number of visible access points is varying, changing in each scan, which is sometimes you're probably familiar with. If you go to select a Wi-Fi network on your computer, oftentimes it will show some additional ones and then it will show less. At least that's something I notice a lot. And essentially what we're noticing is it's not trying to map these at all in terms of like direction. So say this specific access point that we see right here is actually way over here in relation to me. It is not figuring that out. It's just mapping them in terms of how close they are likely to one another. And the straight line here, I think, could be perhaps misleading, because this is making it look like the entirety of all the other access points are either straight forward in that direction or straight backwards in that direction. That's not the case. It's just the way that this is limited to trying to understand which ones are closer together, is not able to decipher at what specific angle they are to me. And it even did mention as much in its initial response right here, where it said something, embedding rather than a literal floor pan solve. With one stationary receiver, you get radial constraints well, but not true angles. So the code infers AP to AP structure from repeated signal trace and lets the layout converge over time. And that's just in relation to which ones of these are closer together. So for example, if I zoom in more here, I don't know that I can. Okay, very good. Let's see. So there's SSID 18. We have the signal strength, which is being read to us right there, uncertainty and distance as well. And these are changing over time as the signal changes when it does an additional scan. But this is basically saying SSID 3 and SSID 13, which now just changed to 19 and 18, would hypothetically be closer together based on the measurable metrics that it sees. And again, this is kind of hard to explain and parse, but it is very cool. And this was the first test that I wanted to run here. So really interesting visuals. It definitely did properly adhere to the stylistic depiction outlined in the prompt. And I do like the kind of coordinates and grid that is slowly panning around. It almost looks like a radar that like does a circle and then it updates and things like that. So this did a very scientifically constrained job of doing this. It was very grounded in reality in terms of what it's actually capable of doing, versus just trying to make it look pretty without much care for actual realistic capabilities versus what would be kind of just almost not hallucinated, but not possible. So interesting. And again, I don't want to speak too authoritatively on perhaps the math and stuff, but this is something that I want folks to see and be able to judge as well, just from, I guess, seeing this. Now for our next test, I think I'd like to do something perhaps a little less brain intensive and a little more fun to play the end generated result. This is going to be a self-contained complete C++ skateboarding game. I do like running this test in the non-very high-end models as well because the results are generally just fun to play, but I also want to do something that will give us perhaps some measure of if this is a massive increase in some capability, even if it's just about the actual trick logic or the models or something like that. Now, I don't want to necessarily modify this prompt too much from when I normally use it, although okay, human with movement on a skateboard, so this is a bit different, and that should be enough for it to understand, hey, maybe I should show like the actual pump of the foot, like kicking to increase the speed of the skateboard. For this one, I will of course keep it on extended thinking mode. I think I want to opt to do this without web search on, just to get a feel for how it performs without that as well. So with that, let's begin this, and inevitably, I'm going to guess, maybe we'll see if I'm right or wrong, I'd say this will probably take 78 minutes to complete this task. So in 44 minutes and 8 seconds, I was in fact incorrect in my initial estimate, but that's okay. It did produce a result. Now, interestingly, just things I noticed initially, it also included the compiled Linux binary built in the environment, which is very interesting, as normally we download the raw C++ script and then build it using some command similar to this. Interesting. Let's build our game right now. Perfect. And then if I can recall what it was called, skate game. All right, let's check out our... Okay, so first thing I'm going to notice, aside from the visual artifacting, the way the arms are definitely like independently just kind of, this reminds me of Simpsons Hit and Run, the video game from back in the early mid 2000s. Some of the folks, when you like knock them over, would just roll around, similar to that. Okay, well, perhaps the camera is just stuck in a ramp or something, and if we move enough, maybe we'll... This is unplayable. This is multimodal, I do believe, right? Yeah, I can take input as an image, and this is the Pro card. I'm honestly going to give it a photo of what we're experiencing and use that to tell it to fix it. So I've given it our screenshot that we took right there when I opened the app initially, which, to be honest with you, makes it appear in a better light than it did in reality once we even started moving. Regardless of that, I think it's cool to be able to give it a photo and a simple description of the issue, which perhaps was a bit lighthearted compared to my normal style of feedback when I received such an atrocious result as this. But regardless, I am interested in seeing what exactly it does based off of this. We now supposedly have a fixed result, and that took around 16 minutes and 50 seconds, and perhaps in lieu of really looking at what it tried to fix here, I think the culmination of this is just fixing some camera movement and clamping or clipping issue with some of the visuals, though it did change the name to fixed, and now hopefully, very good. We have something that we kind of wanted to see from the get-go, although I do have to say it still is kind of odd, and the way it went about fixing the camera made it so it's harder to actually see the player because it's staying so far away as to not interact with any of the ramps and stuff. Regardless, let's just check the animations, okay? J is a kickflip. Okay, not bad. That ramp seems to be completely upside down. K is a heel flip, okay? Q and E are to spin. Okay, that works. The model of the person seems kind of cool, although I have to say, I'm not going to glaze this. I'm overall very disappointed with this result, especially because what I received earlier today with the 5.4 thinking model was significantly better than this and in one shot. And when I say significantly better, the model was much simpler, and it's very likely that this put more thought into this overall in terms of like actually making our character and some of the movement and the trick logic and math behind it and things of the sort. But the fact remains that this is a significant decrease comparatively to the result I saw earlier. So overall, I am disappointed with this result, and I'm not going to sugarcoat that. We're now going to initiate the next test, and I don't know if I should enable web search or not. I guess I will. Yeah, why wouldn't I guess, at this point? I didn't want to keep it enabled for the skateboard one because I just wanted to see what it did relying on its own knowledge, but perhaps that was a mistake. Regardless, this specific test is going to be giving us a self-contained CAD program that allows us to almost drop into an application, and we're giving it freedom in deciding how specifically it goes about creating said application with regards to the language it uses, the way it allows us to run it, whether it's on the web or something like that. And we should be able to draw lines and shapes and extrude them, almost just making a simple CAD program that at the end of it actually allows us to export our shape into an STL so it could realistically be 3D printed. So I'm almost asking it for a very simple CAD design program that will actually work, and keeping the units scaled in millimeters, as that's how I'm used to working in things like Fusion 360. And the ultimate goal here in the culmination of this prompt is I run this, drop into an immersive, distraction-free drafting environment, quickly block out a custom part, and in minutes have a perfect dimensionally accurate STL ready to send to my print farm. I also have said like go all out in terms of the visualization, so I'll be very interested, as beyond the actual logic here of just creating like a CAD program, it's also going to test some of its front-end design capability with regards to whichever specific language it opts to use for this. So our simple CAD result took just under 42 minutes to be generated, and unfortunately I did try to run it because this one I was really quite eager to see at least what the UI looked like, and it had an issue where I could not actually sketch anything. So I sent the model the developer console log from the Chrome browser where I was testing this, and basically just gave it at least a snippet of some of the answers, as well as a very simple description of the issue, and then following around 24 minutes of thinking, it says, "You were right, that was a real bug." Yeah, I know, thanks. And the issue was basically that I could not actually initiate any sketches or select a plane to do so, which will make more sense now when we actually take a peek at this. So I also saved a version copy. Okay, I actually do appreciate that. Let's just now take a peek at this. And it did it in like a, even if we, I don't mean to tease, I know we want to see the result, but it was interesting what it said here. It is going to do dark mode neon UI, so keep that in mind. And here is our simple CAD program. Now I do need to initially make sure, very good. This was what was not working before, was that I could not actually initiate any sketch at all. So I now actually kind of have to figure out how to use this. Let's see if we can select a face, as we should be able to, and I'm just going off of knowing how to use like Fusion 360. So there's no solid yet sketch on XY. Well, I'd like to, perhaps selecting a face needs to, okay, I believe this is only once a solid item has actually been extruded, and that's, I'm mistaking that for a select a plane, which would allow me to kind of change the plane in which I'm drawing the shape on. For now, we'll just kind of ignore that. So I'll select rectangle, and then I guess we'll snap. So this should ideally be a 10 by 10 rectangle. Very good. Okay, let's do a 20 by 40. And I will say the actual snapping to the shapes here, or to the grids in millimeters, is working quite nicely, so I am cool with that. Now I should be able to extrude that, and we did. So we made a simple shape. Okay, whoops, I did not mean to. Good. And one thing I wanted to check is, so we do have our shape here, and I drew another sketch that I did accidentally, but I wanted to make sure that clearing that sketch did not actually clear the initial sketch that led to the one shape we have so far. So let me figure out how to move around. And we can select faces as well, and then hypothetically draw something on that face. So in theory, right now, what we would want to see is if we did a 20 millimeter extrusion here, it should actually start from the top of this rectangle. So it should theoretically start at a height of 20 and then go to 40. Oh, that's cool. It actually, when I selected a face that was different, it changed the grid to reflect that plane, which is kind of neat to see. Still though, I'm having trouble actually drawing anything additional to the shape and extruding it. I'm just getting errors when I try to extrude any other shapes. The operation produced an invalid solid. Try a different feature or a different depth. That cut worked, as we just saw right there, because I set it to extrude to 40. It completely cut a... Okay, so we do have some functionality. It's just kind of hard to, on the fly, use this, I suppose. Nice. Okay, good. That worked. So we were able to, where we had cut it previously, we drew a sketch from there, extruded at 20, which rejoined the entire shape. So that's cool to see. Now, I guess let's just try seeing if we can get a circle done here. And as I use this more, I'm learning how to kind of navigate this better. let's try a circle right in the center here. We'll do, sure. And then, darn it. Let's see if we can cut. No, that would be kind of some complicated leftovers there. Now I'd like to try to join them, and I don't know if I'll be able to. All right, regardless, let's try to export these as an STL and see if we can actually print them. So first order of business, I did in fact 3D print the two specific rectangular shapes that we were able to create with our CAD software that was made with 5.4 Pro. You can see them right here. They were rather cube-like and rectangular, and everything there was actually good. So overall, I just wanted to actually get something physically tangible from that test because that made it feel complete in my mind. So I will be listing these for auction if anyone is interested. We'll start the bid at around 1,000. So this next test is inspired by something I saw just when randomly scrolling through my X feed, where someone had asked a model to make a mock-up of an apartment from the show Friends. Instead, I want to try this with Jerry Seinfeld's apartment from the show Seinfeld, of course. I'm giving it both a reference photo and the ability to do web search. And for the prompt right here, I have just said to it, create an accurate 3JS model of Jerry's apartment based on this floor plan image, include nuanced details, warm lighting, and I almost want to see it search the web for specific things like, oh, there was actually like a 20th anniversary Macintosh on the desk over here, so I'll try to draw that. And basically I want to see how well it actually does this. It also needs to allow us to be able to navigate around the model of the apartment that it creates. Now, I've not yet specifically looked at this, but in 36 minutes and 4 seconds, I started the build and set the project shell, but I did not finish the actual scene yet. I'm curious as to why. So this is actually kind of interesting. I was getting ready to rage at this thing and be like, you're incompetent, like rate your skill on 1 to 10 of how bad you did here. Actually, it stopped because it found a bunch of references, as it mentions right here, saying, hey, the apartment scene changed a lot over time, so I don't specifically know what to do. Like, if you want, I can continue from here and finish the interactive build. And it's saying the most defensible target is a late series / season 8 inspired composite, rather than claiming one single perfectly fixed canon layout. You know what? I respect this and I'm cool with it, and it's giving me a list of strongest must include details for a faithful replica, and I was interested in seeing if it would do that hanging green bike, and it did mention those, so I'm cool with this. And instead of yelling at it, I'm just going to essentially regurgitate what it said it could do, and inevitably it'll take a quite bit of time longer to finish, but I do respect it for being like, hey, I want you to decide like what's specific, being that there's a ton of variability over the course of this show's progression in terms of the set. All right, so after basically an additional hour, it has completed this task. I notice here, just in looking through the chain of thought that we can see following me telling it, yes, go ahead and do what you had initially hypothesized, it was doing a lot of research as well. We even see some reference photos that were not things I initially had given it. We see floor plans, image analysis going on. So I have not looked at this yet because I want to see it for the first time at the same time. All right, so let's hope that this loads without... Whoa, okay, that is really good. Is it? Okay, hold on. I need a moment to look at this. I'm also noticing this specific color palette of like this brown and tan is very common in a lot of the 5.4 results I've been seeing. I don't love it. All right, so this is tough because this did an incredible job of modeling the separate individual items, the bookshelf, the refrigerator, the kitchen, the things like that. The problem is this looks nothing like Jerry's apartment. Oh, well, okay, let me try to, yeah, no. Because Jerry's apartment, technically, if the kitchen is right there, yeah, this is, wait a second. And it even has like presets for us to be able to click in and be able to see those specific things. And like the green bike on the wall, it even, this is, when I'm having trouble deciding what to say because this is really, really well done from a modeling standpoint. This is perhaps one of the finest results I've ever seen of an interior render in all of the model testing I've just ever looked at, because I don't normally do this style of testing, but I have to say, from an actual assessment of the task here, this is not really a proper replica of Jerry's apartment because things are not laid out correctly as according to the floor plan and things like that. Regardless though, if we were to look at this and see how well it did in capturing the individual elements of things that do exist in that apartment, it did a wonderful job. The couch, the bike, the bookshelf, the refrigerator, even the vintage Mac on the table right here with seemingly a printer over there as well, the painting on the wall, the tone in terms of the color, it's very visible, everything looks good. We even have the bathroom drawn, the bedroom is drawn as well, which the bedroom isn't really very commonly seen, even like a Porsche poster on the wall. So this did a fantastic job at getting the individual elements down. It just did a horrible job in arranging them in a way that is reminiscent of the actual apartment setup. So unfortunately, the walking capability doesn't seem to work. It seemed to have placed us, even look at the door here with the handle. Okay, so now we can't, I mean, wow, this is really, this is really good. This is very good. I mean, the items, though, are very, very well made. I love this aesthetic. I would live in a world comprised of this form of visual. Make of that what you will. I don't quite know. Floor plan, provided floor plan reference. Okay, and here's where we can kind of see that things tend to fall apart a little bit, unfortunately. UI is well done, though. The controls, I hate the brown and white color palette, but bedroom, desk, kitchen, living, bath, and this is still in walking mode, so can we? Yeah, we can. Man, this is good. Shift is to speed up. And there's actually like mesh colliders, so I don't know what that looks like. It's mind. Oh, this is wow. I'm impressively frustrated. Rolling, and it's a notepad inevitably. We also have those on the table right here. I do believe that is the phone with the curly cord. New York rolling. I mean, the heater over in the hallway, it even has kind of like the pinkish tile looking at the into the bathroom, and this from this angle right here, this is actually pretty darn good. Next up, I'm going to disable web search for this specific task because I wanted to just rely on the self, I guess could be said. This is the 3D printer simulation test that you may be familiar with from watching the channel. However, this is a specific version of it that denotes the printer must be able to upload, slice, and then emulate the printing process for an uploaded STL as listed right here. So this is something where we want to just see how it does with the general 3D printer as well, with the specific shapes that are outlined in being able to print in this prompt. But then we go a level deeper and make it so it actually has to understand and be able to print simulated uploaded STLs, or real STLs for this printer. So in 76 minutes and 55 seconds, we received our 3D printer simulation result, of course with the ability to upload an STL, slice it, and then simulate the printing. So let's just download this file and take a look at it. I'm very eager to see how this looks. Okay, first and foremost, now I have studio lights pointing at me coupled with a pretty cheap laptop screen that I'm using here, which makes it kind of hard to see. This is so dark. It is actually there and I can see it. The problem is the fog is kind of a bit, now I'm going to manually disable the fog in this result because I want to actually be able to see. That can't be right. I just opened the file to just remove the fog myself. It's 33,000 lines of code. What? Look at this. It did this in 33,000 lines of code in a second. That's monstrous. Holy. Wow. Okay. You know what? Forget the fog. We're just going to, because don't put that on me to fix that right now. Forget that. And that many lines of code in a single file. Good Lord. Okay. So we see the printer is kind of simulated here. There's also a little cube in the center. I'm just going to try to start the print and we'll see what it does. Okay. The movement looks really good, except do I see plastic? It is drawing plastic here. It's just kind of hard to see because the plastic is floating off the bed and perhaps the same color as the... Now the biggest issue here is, oh, So look at that. We can't actually see the shape unless we zoom out like that. The infill, this is so frustrating. Again, it's like another half-baked result. To be honest with you, I think this model has been released a bit prematurely because the stuff I'm seeing is potentially so good, but it's just making stupid mistakes. And this is one of them. So look at that. We're actually seeing honeycomb pattern infill. This is the most realistic infill style I've actually seen, in the way that this is actually going about printing is the most realistic that I have seen, period. The problem is it's just like the fog, and then when you zoom in too much, you can't even see the shape. It's all frustrating in that regard. And because of the gigantic length of that script, I couldn't even really, asking this to fix it would probably take another hour. And it's drawing the skirt around the shape at first time. We have our timeline scrub. So now when we zoom out, we'll actually be able to see the circle, which then will disappear once we zoom in beyond a certain point. But yeah, this is definitely the actual infill and printing process here is incredible. The way I'm seeing this detail that we are partially able to see, and the way it's doing infill, this is hands down the most realistic stab at this that I've seen. Does it finish the top? It does. This is really using completely 100% real printer movements, I suppose could be said. I'm going to try uploading our STL that we had created with the browser-based CAD program. And okay, good. So the glitch is that it shows us this weird box outline of the thing that we have uploaded. And this is, if you recall, the specific shape that we actually had created. So here I will do this timeline scrub, and then we'll have to zoom out to see if it's actually building these. And it is, and it's doing a tremendous job in doing so. I mean, I have these things physically in my hand, and this is literally exactly how they were being 3D printed. So this result is unbelievably cool. It even put the little fan there on the extruder that we would see. The big problem is just some of the rendering is a bit off. And check out the way it will actually do the top layer once it gets there. So when it closes the shape, and that's something we don't commonly see when doing this test, is we don't actually see the preset shapes that we include being closed. With the STL slicing, it's a little different because it would slice in a manner that would know to close the top like this. But it was even doing that just as much when we had the preset selected objects here as well. And it's doing multiple top layers as well. The gantry is, I guess, just kind of floating. It doesn't seem to really be mounted to anything specific, but the way the nozzle moves on the gantry, and then we have this circle on the side there. This is very good, with the caveat that it is kind of a half-baked result just in terms of the way it's rendering, but this is by far the absolute most realistic depiction of how a 3D printer would go about printing any specific object, and the STL file upload and simulated print did work on first attempt. For our final test, I'm going to be giving it in extended thinking mode as well as with web search enabled, the flight combat simulator test that I often like to do with these models. However, this one has been slightly tweaked to make it a bit more complicated. First change from normal is I've specifically told it that I want the 3D graphics to be in a voxel style, with emphasis on realistic plane models and terrain as opposed to anything too abstract, as sometimes I've seen the GPT-5.4 series of models will take this prompt and make weird, like paper plane looking things, which I don't want for this specific test. Additionally, in lieu of the traditional prompt where when you select a plane it just starts you in midair and then the combat begins immediately, this is actually supposed to start at an airport where the player will initially take off, and then that's when the combat planes will appear in midair, so you can have a dogfight or some form of combat simulation. I've also told it that I want realistic sound effects, and we should have the ability to take off and land as mentioned previously. So I'm going to be very interested to see how it goes about doing this, with specific emphasis on how well the graphics look, as well as the overall takeoff and landing and sound effects, and basically everything here. So in 1 hour and 2 minutes and 30 seconds, we did receive our flight combat simulator result, keeping in mind that this is going to be an improved variation over the traditional way in which we test this with models. So I'm just going to download the file, and let's take a peek at it. Okay. I do see a runway there, and I'm seeing some potentially pretty impressive terrain. All right, I'm just going to start mission, and we should have sound effects as well. So let me turn my speaker on. Okay, this is really good, but how do I take off? Uh-oh. How do I... Throttle, shift or control. Okay, so I was not necessarily, I mean, this is the best one. Oh, no, we're going to stall. Okay. Oh, they're the enemies. Good God. This is incredible. This is the single best result for this test I've ever seen. Though it is difficult to play. Oh, it even put a control tower map. I'm putting this game on Steam. $2.99. You can buy this and play it. I need to see how many lines of code. This is incredibly well done. The logic is good. I want to see if I can get a kill. Look at the sun or the moon, whichever. Probably be the sun. I would. Okay. It's really actually quite hard to control this plane. Okay, so I can also use the mouse to shoot, which is helpful. Come on, come on. The sound effects are very well done as well. This is really, really, really good. I don't think I could land again. That's well done. Let's try the final plane that we had not. Oh, cool. It's like a warthog. This is awesome. This is really well done. It seems like I don't think I'm going to be able to get any wins here just because of some of the flight logic, and it does have, like, when we actually start going down, the airspeed increases as well as the sound correlating with the increase in airspeed. So this is really quite cool. Wave cleared. Uh-oh. And the clouds look cool. This should be going faster than that. Wow. I need to see how many lines of code this is. Oh, this is nothing comparatively. This is only 2,300 lines of code. That's probably going to conclude this very lengthy test. So let's just quickly talk about some of these results right here. We of course had our CAD simulation, which took 2 tries to actually produce something working, although the culmination of this was in fact an actual shape that was 3D printed and created, so this was just pretty cool to see. It wasn't perhaps as intricate as I'd imagined or hoped it would be when giving it the specific prompt, but I would imagine this is fairly decent considering, like, to make a full CAD program is probably difficult, and all of the millimeter snapping and drawing and sketching and extruding did work quite nicely, so that was cool to see. Is that our old shape? No, it's just extruding the things I had drawn. And how could we forget our 33,000 line of code 3D printer simulation, which was in fact the most frustrating result I think I've ever seen, because at the same time it was the best result I've received for this test in terms of realistic depiction of how a 3D printer actually prints, the way it was doing infill and things like that. The biggest problem was just kind of the fog and the way that when you zoom in too close to try to look at the shape, it actually just disappears. So that was a little frustrating, but it was able to upload an STL, slice it, and then actually print it, as we can see right there. And I will just speed up the timeline scrub. And this, something else that this did that was really cool was actually closing the top of the shape as well, as opposed to most times when doing this test, they don't actually draw the top layers here and close it. They just keep them open so they always look like this. And again, the infill on this one was also very, very realistic. This had the most adherence to realism in terms of how 3D printers actually print, which was very, very cool to see. Of course, we had our skateboard game, which took 2 tries, and truthfully, I just was not pleased with this result, especially considering the first time was just totally broken, and still, this is just a very glitchy and not well put together result. It has some potential here, but I was overall rather disappointed with this, especially considering that weaker models have been able to produce better results with this specific prompt. Of course, we had our Jerry's apartment sim, which I spend enough time on, so we're not going to go over too much again. But this was, even if it wasn't laid out properly in terms of the way things actually were, like where they should be, the detail here, and just, it was incredible. The way it had different presets for you to actually have like camera views, the floor plan reference that shows up there, and we even can switch into walk, which was just awesome. We also did have the Wi-Fi space mapper, which I'm not going to open back up again because it was kind of simple to look at. It stuck more to adhering to what is realistically possible with that than trying to make something that was visually quite striking, which is acceptable because it kept itself more grounded in reality. And I do have to wonder how much of that was attributable to having web search enabled when running that prompt. And then, of course, how could we forget the singular finest result that I've seen? I mean, this is just, so to be honest with you, I'm going to now have to pull myself away from this result and actually edit this video, which may actually be a bit more difficult than I'd initially anticipated. Yeah, this is just like, oh no, pull up. There we go. Oh, all right. So yeah, that's going to wrap this up. If you have any questions, ask them in my Discord, and feel free to leave comments if you want. And thanks for watching.